Welcome to Sfera, the 3D audio plugin designed by Timber 3D. This tutorial will take you through the plugin user interface and how to correctly use each automation within the plugin for the best results. Before we start, bear in mind that 3D audio is a processed effect, a trick to fool the ears of the listener. There is a learning curve, but that doesn't mean it's difficult to learn. You'll need to develop your techniques, what works and what doesn't. Sfera is a versatile and powerful plugin that, when used correctly, can introduce a new method of mixing for you. What was once just a basic left and right audio source is now all around you. This is the evolution of stereo sound. Remember, Sfera 3D audio is always applied after the initial mix of a project. The reason being is that you need to match your 3D audio levels and reverbs to match the rest of the project. Sfera delivers its best results on headphones, but thanks to our proprietary technology, it sounds great on speakers too. You don't need to use headphones to design your 3D audio. The audio translation from listening on monitors and then switching over to headphones is exceptional. It's like they say, if it sounds great on your monitors, it will sound great on everything else. The last thing you'll want to do is to spend 8+ hours a day wearing headphones. This can cause a lot of hearing fatigue, so feel free to select your monitoring preference. Before you start, please ensure that all your plugin automation parameters are enabled for writing automation. Also, all audio effects selections must be in mono format. Sfera is designed to process mono files for stereo outputs. And finally, place the Sfera plugin onto a stereo aux track. The aux must be in stereo, or else the audio will not correctly output. You can then create as many mono audio tracks as you'd like for placing and layering your audio, but you must bus your audio tracks into the stereo aux track with the Sfera plugin, where it will be processed in 3D. The Sfera aux must then be bused into a stereo audio track where your 3D audio will be printed. Once you finish printing the new 3D audio track, disable the plugin. Sfera takes a lot of processing power and can slow down your session. Never keep Sfera enabled when it's not in use. Remember, all your automation is written into the Sfera aux track, so if you need to revisit a 3D effect for changes, simply enable Sfera, make your automation changes, and reprint the 3D audio track. Please ensure that the output of your print track goes directly into your main speakers and is not routed into further tracks to ensure that there are no audio delays. Once you print the 3D audio track, you can move the clip into the delivery or mix session as an independent file. If you plan on using additional plugins for changing the way your effects sound, such as using EQs, guitar amps, speaker emulators, and so on, make sure that this process is done before the Sfera plugin within the signal chain. The job of Sfera is to take all of your designs and emulate them into a 3D environment. Placing the plugins after Sfera on the chain can result in destroying the 3D effect. If you wish to roll off some of the low end of your sound effects going into Sfera using an EQ, you can roll up to 120 Hz without dramatically impacting the 3D effect. To start off, the user interface can easily shrink or expand to suit your preference by simply dragging the bottom right corner of the window. Heading over to the visual map, you will see two icons. The first icon that looks like a speaker is your source audio. This icon moves your selected audio around the map. The second icon that looks like a pair of headphones is your listener. This icon mimics your ears and is used to listen to the source as it moves around the map. The listener can also move around at the same time as the source to simulate body movement. There are two more hidden movement automatons found under the Sfera automation section of your track. They are called Listener Y and Source Y. These automation selections allow you to automate the height of both source and listener. By default, they're set to 1.8 meters high, which is roughly the height of a person. The automation list for listener and source also have X and Z coordinates. X represents left and right movement on the map. Z represents up or down movement on the map. Moving on to the environment section, it's made up of three selections: groups, room size, and meters or feet switch. The group selection allows you to create presets of up to 4 different room sizes. The room size allows you to set the width, depth, and height of each room. The meters or feet switch allows you to select your preferred unit of measurement. For this tutorial, we will maximize the width, depth, and height to simulate an outdoor setting. Before we move on to the next sections of the user interface automations, let's first automate the movement of the source icon on the map. And now that the source movement has been automated, we can proceed to the remaining sections of the user interface. The next section is called Source. This is made up of the yaw and speed selections. The yaw is the rotation of the source object. It's very important to set the correct rotation of the object to simulate where it's pointing as it travels. This will dramatically change the audio characteristics in terms of audible frequencies and where the reverb reflections will travel. The front of the source icon is visually represented by the circular dome. The speed selection allows you to set the speed and Doppler effect of your source movement. Speed is expressed in meters per second. For the most part, you can keep the speed set to its maximum setting for the most amount of flexibility. But if you find that the source is creating artifacts in the sound, bring down the speed automation to match the movement automation you created when you automated the movement of the source on the map. If your speed is too slow, the audio will lag behind your movement automation. You'll know you've gone too far when you see the red target lag behind the icon. In this instance, bring the speed slightly back up until the red target matches the speed of your source icon. The next section we will look at is the reflections group. Sfera has one of the most sophisticated reflections engines in the market, which helps create a truly immersive and convincing sensation of 3D movement and placement. This section is made up of order and damping. Order emulates the amount of objects within a room that the reverb will reflect off of. Order can be set using the slider from the range of 0 to 4. The slider should never be set to 0, as it means that the reverb will be turned off. When the slider is set to 1, this emulates an open field without any objects for the reverb to bounce off of. When the slider is set to 2, this emulates an open field with a few objects within the area. When the slider is set to 3, this emulates a suburban area. There are houses all around, but not as dense as a bustling city. When the slider is set to 4, this emulates a city with a lot of reflective surfaces. Areas such as jungles, although dense with trees, wouldn't be set to 4 because trees are not as reflective as buildings made of brick, steel, and glass. A jungle may be set to 3 instead. Sometimes, if the trees are far apart, a 2 would do just fine. Use your ears and make a judgment call. The next selection of the reflections group is damping. Damping is the attenuation of the low and high frequencies. The slider is set to 0 by default, which means that there's no attenuation of the audio. The slider can go from 0 to +6 to attenuate the high frequencies, or it can go from 0 to -6 to attenuate the low frequencies. The rule is, the further the object moves away from you, the more the high frequency becomes attenuated. In an outdoor setting, the furthest point from the listener, which means the source would be at the edge of the map, would be +6 in attenuation. The midway point between the listener and the furthest point is +3. The closest point to the listener, which means that the source is directly beside, in front, or behind you, is 0. Using this simple scale, you can apply the same logic for the remaining automation parameters that require measurements for distance. Don't worry, we'll go through them as we move along. The second last section we will look at is called levels. The levels group is made up of master, HRTF, reflections, drop-off, and presence. Master is the overall audio output. By default, it's set to 0 dB. You'll never need to touch this slider because you can adjust the volume automation using the Sfera aux track, but the master slider is there if you need it. HRTF is the technology used to create the 3D effect. The switch should be set to on by default. If the switch is turned off, it will be marked with a red dot. This red dot is used for occlusion, which means that the source is not in the line of sight of the listener due to an obstruction in the room. In this case, all you'll be able to hear are the reflections. An example of an obstruction could be a wall. You can click the switch to go back and forth between both modes. The HRTF slider is automatically set to 0 dB, which by default provides the most realistic results for 3D audio. Sliding it down can reduce the 3D effect, while sliding it up can exaggerate the 3D effect. For the most realistic application, keep it set to 0 dB. Reflections is the wet and dry effect of the reverb. This should be adjusted during the final step of the process to match the mix of the project. You can keep the audio dry in the meantime until all other parameters have been automated as needed. Drop-off is the amount of frequencies and details that remain or deteriorate as the source moves further away from the listener. If the object is directly beside you, the drop-off would be set to 0. If the object is at the further point of the map, it would be set to 9. The midway point between the furthest point on the map and the listener is either 4 or 5. You can choose according to taste. The final selection of the levels group is presence. This is a very sophisticated filter that changes the characteristics of the HRTF. It can be used to adjust how present or sharp the source audio is. When the source is directly beside the listener, the presence can be set to 1. When the source is set at the furthest point away from the listener, the presence can be set to 0. However, the right settings will depend on the characteristics of the sound. Your minimum and maximum settings may be different for each sound effect and should be set by ear. The final group is called listener. This group is made up of the yaw and pitch selections. The yaw slider, just like the yaw selection in the source group, adjusts the rotation of the listener. This automation is great to use when the camera changes angles or pans. Pitch is simply the tilt of the listener looking up or down. Adjust it as necessary. Now that all the prioritized automations are written, the final step is to go back to the reflections sections in the levels group and automate the slider to match the reflections of the project mix. Remember, this example was set in an outdoor environment. In a small room, let's say a 4-meter by 4-meter bathroom, your scale is much smaller. Come up with a scale that works for you, with every variation of room size. Sfera is a very versatile plugin. When it's used correctly, it has the capability of enhancing your mixes to the next level of immersion. If you would like to start working right away without the hassle of creating a template, we've already made one to get you started. Download it for free. We're also offering one-on-one online work sessions to show you good workflows and to answer any questions you may have. Thank you for joining us. We hope this tutorial was helpful. Get creative and have fun.